Type a web address, hit enter, and the page loads. What exactly is happening behind the scenes to make that connection possible? Computers operate on mathematically rigid systems. They cannot guess your intent. They require strictly defined rules to exchange any piece of information over a network. We call these rule sets protocols. Think of a protocol as the digital equivalent of a shared human language, ensuring both the sending and receiving computers understand each other perfectly. By the end of this tutorial, you will know exactly how to audit the protocols running in your own browser, giving you the ability to manually verify the security of any website you visit. Skipping this verification step means your personal data, like your passwords, your private messages, and banking details, could be actively exposed to interception across the open internet. To see these rules in action, look up at the address bar at the very top of your current active web browser. The very first segment of a web address identifies the specific data transfer rules being utilized. Often, this is HTTP, which stands for Hypertext Transfer Protocol. With standard HTTP, data travels in plain text, meaning any middleman can intercept and read your information. To solve this, we use HTTPS. The data packet now scrambles into a complex cryptographic cipher before leaving your device, rendering interception completely useless. You don't need to read the cipher yourself to know it's working. Looking at this browser mockup, clicking the padlock icon immediately displays a menu confirming your connection is encrypted and secure. You need to watch out for hidden URLs, however. Modern browser interfaces often conceal the actual HTTPS prefix by default to keep the visual display clean. To reveal the full, unhidden protocol string, simply click the padlock icon or click directly into the address bar text until the hidden characters appear. That single S in HTTPS is the mandatory baseline for web privacy today. Without it, your browser is broadcasting your activity in the clear. Now that we know how data travels securely, we need to look at where it is routed. How does the network locate the destination server? Computer networks navigate strictly using numeric IP addresses. They cannot route traffic using alphabet-based domain names like the ones we type. To bridge this gap, the internet uses the Domain Name System, or DNS. It acts as a dedicated translation directory between your human input and the machine routing. In this digital directory interface, submitting a standard domain name like google.com initiates a DNS lookup as an input query. The directory processes that text and outputs a numeric IP address string, like 142.250.190.46, providing the exact mathematical coordinates the network needs. This setup provides a massive usability advantage. It eliminates the need for you to memorize long strings of numbers for every single website you want to visit. DNS is an absolute requirement. It reconciles our biological memory constraints with the strict mathematical requirements of internet routing. Let's synthesize these concepts into a single chronological timeline, starting the exact moment you input a domain name and hit enter. Follow the glowing data pulse. It leaves the user node, pauses at the DNS server to resolve the IP address, and aims toward the web server. The pulse hits the server and returns via a secure HTTPS line marked with a padlock, completing the circuit. This entire multi-stage sequence of routing the address, validating the security, and transferring the data executes in milliseconds upon every single link click. Combining DNS routing and HTTPS encryption guarantees two specific necessities. Your data accurately reaches its destination, and it remains fully protected while in transit. We have now covered the core technical triangle that drives web connections: communication protocols, HTTPS encryption standards, and DNS translation. Your practical homework is to evaluate the security posture of 3 websites that you visit frequently. Here are your exact audit criteria. Actively verify the presence of the padlock icon and click into the address bar to check for the unhidden HTTPS prefix. Log your findings in a notebook or text document to solidify your understanding of your own personal digital footprint security. Performing this manual browser audit elevates you from being a passive consumer to an active, security-conscious participant on the internet.